Hello everyone. Today we see about the basic buffers and applications of buffer solutions and buffer capacity. See the first basic buffers. So what is meant by basic buffer means the buffer solutions which are prepared by the mixing of weak bases with salts formed by them with a strong acid. Okay, so generally they prepared. So the basic buffers are prepared by mixing weak bases and their salts with a strong acid are known as basic buffer solutions. Very important here examples. So to identify, so it is very important to identify a buffer solutions. That is, a given solution is acidic buffer solution or basic buffer solution. We have to identify. That identification is very important. But simply if you see the weak base, simply we can say it is a basic buffer. If you see the weak acid in it, we can say it is a acidic buffer solution. So now we see some examples. So basic buffer, so ammonium hydroxide is a weak base. See ammonium chloride. So ammonium hydroxide is what? It is a weak base. So what is ammonium chloride? So it is the salt of ammonium hydroxide with HCl. We know the reaction of NH4OH plus base, plus HCl. Acid plus base reaction, there is a formation of water and ammonium chloride. Means what we done here? The mixing of weak base and its salt. Its salt is formed by the strong acid. Okay, so this salt is formed by this weak base and strong acid. So this mixing works as a basic buffer solution. Okay, let's see one more example. See calcium hydroxide. Calcium hydroxide is again it is also a weak base. When it reacts with a strong acid HBr, there is a formation of calcium hydroxybromide. So this is weak base. So this is the salt. The salt of this calcium hydroxide with the HBr. Okay. So like this, so the mixing of weak bases and the salts of the weak base with a strong acid works as a basic buffer solutions. Okay. Now we see working of basic buffer solutions. See the basic buffer solutions working. So in working of basic buffer solutions, we explain. So why there is, already we know the definition, buffer solutions definition. According to definition, what we know, if the addition of a strong acid, few amounts of strong acid and few amounts of strong base, there is no change in the pH of the particular solution. Means the solution which resists, the solution which opposes the change in their pH by the adding few amounts of strong acid or few amounts of strong base, even on dilution. Okay, so why they are maintaining means even by the addition of acids, there is no increase or decrease in the H plus ion concentration. So by the addition of strong base, nothing but OH minus ions, there is no change, there is no decrease in the OH minus ion concentration. Therefore, finally there is no change in the pH. So how it is happening? We see the working of buffer solutions. Already in the last session we completed the working of an acidic buffer solution. Now is the working of this basic buffer solution with an example. Okay, so the example we are taking here is to explain the basic buffer working is a weak base and it's a salt. Weak base ammonium hydroxide and it's a salt with ammonium it's salt with HCl. This works as a basic buffer. How it works as a basic buffer? So first we see on addition of acid what happens. Okay, see the case 1. Adding of a few amounts of strong acid. So what happens? So after adding few amounts of strong acid, what we expect? Strong acid add just automatically I am expect just the H plus ion concentration increase. So H plus ion concentration increase cheste automatically it's originally it is having basic character, so its basic nature somewhat decreases because when I add this acid releases H plus ions, why so neutralize some basic nature strength decreases chance undi, but it is not happening. Why? And when acid add cheste acid nunchi release H plus ani మనం increase our H plus ion concentration, but whatever the H plus ions are released into the solution are taken by ammonium hydroxide. So ikkada manaki form a reaction entante what we expecting, the adding of a few amounts of strong acid, there is releasing of many number of H plus, but whatever the H plus ions added, they are absorbed by, reacted by this NH4OH weak base and forming neutral water. NH4 plus this OH minus combines it forming H2. And then whatever the H plus ions, strong acid, H plus ions పంపిస్తున్నాడు with the help of strong acid. So acid లో release అయిన H plus ions మొత్తం NH4OH react అయిపోయి neutral H2 form చేసింది. అంటే there is no increase in the H plus ion, there is no decrease in the H plus ions. Okay, అంతకుముందు ఎన్ని నెంబర్ ఆఫ్ ఎంత కాన్సన్ట్రేషన్ ఆఫ్ H plus ఉందో నువ్వు స్ట్రాంగ్ యాసిడ్స్ యాడ్ చేసిన తర్వాత కూడా అంతే కాన్సన్ట్రేషన్ ఆఫ్ H plus ఉంది. So there is no change in the pH. So we can say, so the adding of a few amounts of strong acid the H plus ions released by strong acid or combines with the NH4OH forming neutral water. So therefore no change in H plus concentration and no change in pH. Okay, next we see what happens when a strong base is added to the solution. Now see the case 2. So in case 2 we are saying adding of a few amounts of a strong base. Okay, you have to write again. So what happens when adding of a few amounts of base to the buffer solution, this buffer solution, what happens if a strong base is added? What we expecting? We expect the OH minus ion concentration released. The OH minus concentration increases due to the addition of the strong base, which releases OH minus ions, but there is no change in the pH because whatever the OH minus ions released by the strong acid are combined with the NH4 plus of this salt and become NH4OH. Means NH4 same type of base form avutundi, same type of strength unna base form avutundi kabatti, so there is no increase in the OH minus ion concentration and there is no change in the pH. Means here we can write the step. The OH minus ion released by the strong base are combined with the NH4OH and forming the same strength base, that is NH4OH. Means here we can write the OH minus ions released from strong base are combined with the NH4OH forming an undissociated base, that is NH4OH. So therefore there is no change in the OH minus concentration. And no change in pH. So like this, even by the addition of a strong acid, even by the addition of strong base, there is no change in the H plus ion concentration and OH minus ions concentration respectively. Finally, there is no change in the pH. That's why this mixture works as a good buffer solution. Okay. So this was about working of basic buffer solution. So actually there is also one more concept to explain the working of acidic buffer solution and basic buffer solution is a common ion effect. Okay, which is perfectly comes in further chapters. Okay. Let's see. It's a very important one, that is buffer capacity. Buffer capacity, so it's called phi. Okay, it's called phi. It's known as, it is named as phi. Okay, so what is buffer capacity? So means we know many number of buffer solutions. We know that buffer solutions definition that they reserve their pH, means they do not allow the change in their pH value by the addition of few amounts of strong acids and strong base. But for example, here we are taking two samples. Okay, we are taking two samples of buffer solution. Name it as buffer 1. So name it as buffer 2. Okay. So we are taking two samples of a buffer solution. So both are having, so here it is having pH value 1. So it is having pH value, okay, for example 4. Okay. So next. So how to check the buffer capacity means here we are taking how much amount. So we have to a perfect standard value undali kabatti, so idi 1 liter తీసుకుందాం, ఇది 1 liter తీసుకుందాం. 1 liter of buffer 1, 1 liter of buffer 2. It is having pH value 1, it is having pH value 4. Okay, ఏ pH value అయినా తీసుకోవచ్చు, no problem. అయితే మనం స్లో కదానికి యాక్చువల్గా బఫర్ సొల్యూషన్ అంటే మనం స్ట్రాంగ్ యాసిడ్ యాడ్ చేసినా, స్ట్రాంగ్ బేస్ యాడ్ చేసినా దాని pHలో చేంజ్ రావద్దు. ఓకే, అంటే H+ ion concentration, OH- ion concentration లో there is no change ఉండాలి. So for example, in case of a strong acid, we are adding strong acid, or we can add strong base also. Okay, just for testing purpose, we can add strong acid or strong base. So then we are adding slowly to the strong acid. Okay, slowly drop wise add chedam. So for example, adding 1 ml, 2 ml, atla 1 slowly 1 ml, 1 ml drop wise add chedam. So add just to middle em cheyalante, we have to check the pH values of these solutions. Just to 1 or 2 drops add cheyadam, 1 or 2 milliliters add cheyadam. Next mali pH check cheyadam. So how to check the pH means simple. There is a pH papers are there. So pH papers is nothing but it's an old method. Color perfect ga identify cheyali pH papers aithe okkoka pH దగ్గర ఒక్కొక్క కలర్ వస్తది. Identification of color may be confusion already, but in the recent times we are having pH meters. pH meter just మన పెన్ సైజ్ లో ఉంటాయి. ఆ pH meter ఆ సొల్యూషన్ లో డిప్ చేస్తే అలా డిప్ చేసి ఉంచితే సరిపోతుంది. ఆటోమేటిక్ దాంట్లో pH వాల్యూ ఎప్పుడు రీడింగ్ కంటిన్యూస్ గా చేంజ్ అవుతూనే ఉంటుంది. ఇఫ్ pH చేంజ్ అవుతే చేంజ్ అవుతుంది. Okay, so atla pH meter toni we have to check the pH. So atla pH check, for example దీంట్లో pH value ఎంతంటే its pH becomes 5. So after adding 20 milliliters of acidic, 20 milliliters of strong acid add చేస్తే దీని pH value 4 నుంచి 5 వచ్చింది అనుకుందాం. ఓకే, సారీ 4 నుంచి 3 వచ్చింది అనుకుందాం. Okay, acid add చేస్తున్నాం కదా, it become a stronger one. Next, its pH value becomes 0 and a 1 unit change, it may be increase or decrease. Okay, so after addition of 30 milliliter, first solution లో pH value 1 unit acid addition కాబట్టి జనరల్ గా pH value decrease అని చెప్తాం, స్ట్రాంగ్ యాసిడ్ కాబట్టి. సో యాక్చువల్గా అయితే pH వాల్యూ నో చేంజ్ ఉండాలి. నువ్వు కొన్ని ఎంఎల్ యాడ్ అయ్యే వరకు ఇట్ ఈస్ మెయింటైనింగ్. కొంచెం వాల్యూమ్ ఆఫ్ స్ట్రాంగ్ యాసిడ్ యాడ్ చేస్తూ ఉంటే దాని pH కెపాసిటీ రెసిస్టెన్స్ చేసింది. బట్ ఆఫ్టర్ అడిషన్ ఆఫ్ ద 20 milliliter యాడ్ చేసినప్పుడు మాత్రం దాని pH చేంజ్ అయిపోయింది. మీన్స్ దాని కెపాసిటీ 19 ml వరకే ఉంది. 19 ml యాడ్ చేసినంత వరకు there is no change in the pH, that resist చేసుకునే capacity వచ్చింది. But after addition of the 28 milliliter, it changes its pH value from 3 to 4. Sorry, 4 to 3. Okay, first మనం తీసుకుంది pH 4 కదా, it becomes 3. అంటే pH value decrease means its acidic strength increased. Whatever acidic strength increase or decrease or whatever, but pH value change అయింది after addition of 20 milliliter of acid. అదే మనకి బఫర్ సొల్యూషన్ 1 లో ఇదే చేంజ్, దీంట్లో కూడా 1 యూనిట్ డిక్రీజ్ అయింది pH వాల్యూ. ఇక్కడ pH వాల్యూ 1 యూనిట్ డిక్రీజ్ అవ్వడానికి 20 milliliter యూజ్ అయింది. ఇక్కడ pH వాల్యూ మనం 120 డిక్రీజ్ 1 వాల్యూ డిక్రీజ్ చేయడానికి 30 milliliter ఆఫ్ స్ట్రాంగ్ యాసిడ్ యూజ్ చేయాల్సి వచ్చింది. అంటే ఇది 29 milliliters వరకు రెసిస్ట్ చేసుకునే కెపాసిటీ ఉంది దీనికి. 30 ml దగ్గర యాడ్ చేసిన తర్వాత దాని రెసిస్టెన్స్ పవర్ పోయింది, pH వాల్యూ చేంజ్ అయింది. అంటే విచ్ ఈస్ ద బెస్ట్ బఫర్, అంటే విచ్ ఈస్ ద స్ట్రాంగ్ బఫర్? ద ఫస్ట్ వన్ ఈస్ ద స్ట్రాంగ్ బఫర్ కంపేర్ టు దిస్. ఓకే, కాకపోతే ఎన్ని యూనిట్స్ కంపేర్ చేస్తే మనం 1 యూనిట్కి. ఒక బేసిక్ బఫర్ యాడ్ చేసినా కూడా సేమ్ pH వాల్యూలో చేంజ్ 1 వచ్చే వరకు, pH వాల్యూ చేంజ్ 1 వచ్చే వరకు మనం యాడ్ చేయాలి. ఆ pH వాల్యూ 1 రావడానికి హౌ మచ్ సొల్యూషన్ ఈజ్ యూజ్డ్, దాన్ని మనం ఫైనల్గా నెంబర్ ఆఫ్ మోల్స్లో కన్వర్ట్ చేస్తాం స్టాండర్డ్ వాల్యూస్కి. అన్నిటికీ సేమ్ ఉండాలి కాబట్టి మనం అన్నిటి 1 లీటర్ తీసుకుంటాం. అన్నిట్లో చేంజ్ 1 యూనిట్ చేంజ్ అవ్వాలి, ఇట్ మే బి డిక్రీజ్ ఆర్ ఇట్ మే బి ఇంక్రీజ్. అంటే ఇక్కడ దీన్ని 20 ml యాడ్ చేస్తే ఆటోమేటిక్గా pH వాల్యూ చేంజ్ బై 1 యూనిట్. సో ఫస్ట్ సొల్యూషన్ మాత్రం 30 ml యాడ్ చేస్తే ఇట్స్ వాల్యూ చేంజ్ బై 1 యూనిట్. And it is having more capability, more resistance power than this. Means ఈ amount buffer capacity value ఎక్కువ ఉంటే nothing but it is a best buffer. The letter is a good buffer అంటే that nothing but it is a best buffer and meaning. Okay, so now we see a definition, a perfect definition for it. So we can define the buffer solution is the number of moles of strong acid or strong base added to 1 liter of a buffer to change in its pH value by 1 unit is called buffer capacity. Okay, so buffer capacity generally, so the formula that we can say 5. Okay, 5 is equal number of moles of strong acid or strong base added by change in pH units. Okay, so ఎందుకంటే మనకి ప్రాబ్లమ్స్ లో ప్రతిసారి 1 యూనిట్ చేంజెస్ కి 2 యూనిట్స్ కి 3 యూనిట్స్ కి చేంజ్ అయిన ప్రాబ్లం ఇస్తాడు. The addition of some mole, there is a pH value changed from 3 to 6. Okay, pressure 1 unit ఇవ్వకపోవచ్చు, but whatever it is, whatever the number of units are given, we have to calculate it for 1 unit. కాబట్టి by change in number of pH units into volume of buffer in liters. Okay, this is the main formula used in the problems. Okay, in books one more formula is also given. So actually this is the very suitable for calculations. Okay, we can write the one more formula, that is phi is equal to n by changing pH. So this type formula also will be given, but so what is n? That n is a here important one. N is the number of moles of strong acid or strong base added to 1 liter of buffer. Added to 1 liter of buffers. అంటే నెంబర్ ఆఫ్ మోల్స్ డైరెక్ట్గా వాడు ఎన్ని లీటర్స్కి ఇచ్చినా మనం ఈ ఫార్ములా యూజ్ చేస్తే 1 లీటర్కి ఫైండ్ అవుట్ చేసి తర్వాత దీనిలో సబ్స్టిట్యూట్ చేయాలి. సో ఈ ఫస్ట్ ఫార్ములా ఏంటంటే, సో వాట్ ఎవర్ ఇట్ ఎంత వాల్యూమ్ ఇచ్చినా మనం దీనిలో సబ్స్టిట్యూట్ చేస్తే we will get the answer. Okay, means now we also understood that 5 value. So buffer capacity ఎక్కువ ఉందంటే it's having a more capacity. Okay, generally best buffer proportional to 5. So in some questions it is also given that some buffer capacities are given. Which is the best buffer? Which is the best buffer means which is having more volume capacity of acid or bases which is added to it. Ekko buffer capacity undante that is the best buffer. Okay, means best buffer is directly proportional to 5, and it is also noted. It's also very important concept. So the buffer solutions so for acid, for bases it is different. the acidic buffers in which milli equivalents of weak acid and milli equivalents of salts are same, it works as a best buffer. Okay, means acidic buffer అన్నప్పుడు కంపల్సరీ దాంట్లో వీక్ యాసిడ్ ఉంటుంది అండ్ సాల్ట్ ఉంటుంది. ఓకే, సాల్ట్ అంటే నథింగ్ బట్ దాని కాంజుగేట్ బేస్ అవుతుంది. ఓకే, ఫర్ ఎగ్జాంపుల్ if you take a weak acid take a hydrogen cyanide. Next add a salt of it with a weak base tone it's a salt ante what is the weak base we are taking? NH4OH. So what is the formation of H2O, OH, H plus, remaining NH4Cl. So NH4Cl, HCl, it's a salt with it's a salt with a strong base. It's a salt with a strong base. HCl. What is the strong base? Take a sodium hydroxide. So the Cl Na becomes a NaCl. Okay, NaCl. Now see, this works as the acidic buffer. So weak acid. Next is the salt with a strong base. NaOH. So these manam conjugate acid base pair ga treat cheyochu. Because what is the difference? H plus Na plus. Only one H plus is the difference. Na plus difference nu dani manam consider cheyam. One H plus difference undi kabatti it can be treated as its conjugate base. Okay, if the salt concentration nothing but its conjugate base concentration, this acid concentration are same, then it works as a best buffer. So it was given experimentally and with help of some other equations. What are that equation? In the next class we see it. It means here we can say pH equal to means acid concentration equal salt concentration equals nothing but acid concentration. It is also noted pH is equal to P power K. It is a condition for a best buffer. Okay. In the same way, we can write it for basic buffers. For basic buffer solutions, if salt, again it is also having salt concentration equal to base concentration, nothing but POH is equal to P power KB. So for base always PKB is there, so POH is equal to PKB. It is a best buffer. Okay. So this is about the buffer capacity. We have some problems on this buffer capacity. Let's see a small topic in it, that is applications of buffer solutions. So applications of buffer solution. So actually the buffer solution means reserving their pH, the controlling in their pH of for solutions is very important in many biological reactions. They are known as biochemical reactions. They have very important role in biochemical reactions, simply we can say. So biochemical reactions means mainly the reaction takes place in the human beings, okay, or any biological systems, okay, but the main important for us is the many chemical reactions takes place in our body are also comes under biochemical reactions. The working of enzymes, or the working of hormones, formation of hormone, formation of enzymes, and even particular blood also must controls its pH. Its pH around 7 point something is there, 7.2 or 3 is there. It always it should maintain pH value, that only. If there is any change in the pH value of blood, so it is nothing but it is a disease. It causes many type of diseases, maybe leads to death. Means it never happens. The pH value of blood is always in under control. Means it also works as a buffer solution. Actually, due to the presence of bicarbonates, due to the presence of bicarbonate buffers, it maintains its pH value as a stable one. Okay, means simply we can say they have very important role. They have very important role in biochemical reactions. Next, very important here, bicarbonate buffer. Just now we said about blood. In blood, so bicarbonate buffer is present in blood. Simply we have to remember. So it is in biochemical reactions, it is very important. Okay. So it is also known as the enzyme catalyzer reactions. Enzyme catalyzed reactions. So what are enzyme catalyzer reactions? Means already we know the many types of enzymes are released in our body. So what is the purpose of the releasing of enzyme? Means there is a particular purpose is there for particular enzyme. ఒక్కొక్క ఎంజైమ్ ఒక్కొక్క వర్క్ చేస్తుంది బాడీలో. దాన్నే ఎంజైమ్ రియాక్షన్ అంటే ఆ రియాక్షన్స్ బాడీలో అవ్వాల్సిన రియాక్షన్స్ ఏమవుతాయి అంటే ఈ ఎంజైమ్స్ యాడ్ అయితే పర్ఫెక్ట్ అవుతాయి. వితౌట్ ఎంజైమ్స్ ఆ రియాక్షన్స్ అవ్వవు. దట్స్ వై దే నోన్ యాజ్ ఎంజైమ్ క్యాటలైజ్డ్ రియాక్షన్స్. అంటే ఎంజైమ్స్ వర్క్స్ యాజ్ catalyst for that reactions. So enzyme catalyzed reactions nothing but enzymes also maintains the controlling pH. Next, so one more very important is even in the industries. In industries also they use many number of buffer solutions. For example, in the soap industries, for soaps also they must maintain a perfect controlling pH. Okay, means simply we can say in the industrial solutions, buffer solutions are used in industrial synthetic processes. They are also used in chemical analysis. Okay. They are also used in chemical analysis. So one more important, they are also used softening of hard water. So what is meant by softening of hard water? We know that water is mainly two types based on the salts dissolved in it, the hard water and soft water. Hard water does not give good lather with soap solution. It is not useful for even for clothes also. For even they are not used for cloth washing of clothes. Not for drinking, not for cloth washing, for bathing also not useful. I have to convert them into soft water. In the soft water converting we use some chemicals. That chemicals are also generally buffer solutions. Okay, means next one more. So we know there are many number of fruit juices in the market. Fruit juices also must maintain controlling in their pH, because the change in the pH also makes a lot of problem, maybe damaging the food. Means that fruit juices are also best examples for buffer solutions. Means in the fruit juices they add some content, some compounds, some buffer solutions which which controls the pH. If pH changes, so the damage of the food takes place. Okay, means we can write many fruit juices are also best examples for buffer solutions. Okay, so from tomorrow we see the problems on buffer solutions. Okay.